morning. I'm Dr. Senthil Kumar, Associate Professor, Department of ECE, Program Engineering. So today we are going to discuss about communication systems and the advantages of communication system and modulation, and also the types of modulation. Initially, if you are considering a communication system which contains three parts, the first one is transmitter. The output from the transmitter will pass through the channel and reach the receiver. So this is the basic block diagram of a communication system. Here we would like to transmit a signal from the transmitter. So any source can be used to transmit. The same information has to be received in the receiver or replica of the source. So our ultimate aim is we have to transmit an information from one end to another end. Here the one end is transmitter, other end is receiver. So the information is here nothing but our message signal. Information or message signal or modulating signal. I would like to transmit the information from the transmitter side through the channel and try to reach the receiver. So in this aspect, we have different types of communication systems. Starting from analog communication, digital transmission, digital communication. So in all the cases, we have some information either in analog format or digital format. Our ultimate aim is to transmit the information from the source end to the destination. But here, the main problem is that we are having information, but actually that is in the range of very less frequency range. If we try to transmit the information that is less frequency information, it is not able to reach the destination because of we don't have enough time. So now what we are going to do is we have to add something to the information. So here that is called as a carrier. So less frequency message we are having, we have to add some carrier signal with this. So obviously high frequency carrier signal. This process is called as modulation. For example, if I am having a message signal, the range of the frequency of message signal is 100 Hz. But if I would like to transmit the 100 Hz message from the source end, that is from the transmitter to the receiver side, not able to reach the receiver because of the low frequency. So I have to increase the frequency level, but not possible to increase the frequency of message. So I have to add some carrier signals. Here maybe 10 kHz carrier signal is in. So now the total signal is around 10,100 Hz because I am adding some carrier signal to the message signal. So with the help of the carrier signal, our information can be able to reach the receiver. So at the receiver end we are having both message and carrier signal. So we have to remove the carrier from the message and only we can able to obtain the original information. So this process is called as the modulation. So modulation happen at the transmitter. The reverse process will happen at the receiver named as demodulation. So for the modulation process, so we have to use two signals. So one is message signal, another one is carrier signal. So we are having message and the carrier signal. So the important information is if you are having high frequency message signal, that there is no need of carrier signal. Suppose if you prefer a 100 hertz carrier signal, that is not useful to transmit the information from the source to destination. So you have to choose a proper message signal frequency and carrier signal frequency. Then only the signal can able to reach the destination point without any issues. Now, if you are considering the message signal has only 100 hertz frequency, I would like to add the high frequency carrier. So here, the carrier frequency should be a single tone frequency, because this value should be constant from the transmitting end, that is from the modulation process. For the entire modulation process, the frequency should be a constant frequency. So this is single tone frequency, but your message is a multi-frequency message, or in some cases it can be a single frequency. Suppose if you would like to transmit a recorded voice, at that time single frequency is considered. So maybe 100 hertz, no problem. So we can able to transmit these two signals. So one is the carrier should be a single tone frequency. The message is either multi-frequency or single frequency. Now if you consider the message signal and the carrier signal for analog communication, if you are taking an analog communication here, right, the message signal should be in the form of analog. The carrier is also analog. For as well as for digital transmission, the message is digital. The carrier is also digital. Suppose if you are having an analog communication, if you are focusing on analog communication with analog message signal and analog carrier signal, the advantage is the signal can be able to propagate through free space. But unfortunately, the accuracy will be less at first, because we don't have any digital signal in the information. So the accuracy will be very less. But one advantage is we can able to propagate through free space. If you are focusing on the second one, digital transmission, that time we can choose the message as digital signal, carrier is also digital. Unfortunately, here the signal cannot propagate through free space because we are having only digital signals, zeros and ones. So that is the biggest disadvantage of digital transmission. The advantage is accuracy will be high, because we are dealing with the digital signal, even though if there is any error, that can be removed easily by means of frequency. The final one is digital communication. For example, if you are considering analog message and digital carrier, then what will happen? Suppose if you imagine that your message is analog message, your carrier is digital. If you are having a digital carrier, then it is not possible to propagate through free space. That is the problem with respect to the digital transmission. Similarly, if you are using analog message, that time also you have to face a problem, that is nothing but the problem related to analog communication. That is, it has less accuracy. So we never prefer analog message and digital transmission. So vice versa, we have to prefer digital message and analog carrier. So because of the digital message, the accuracy will be increased, and because of the analog carrier, the signal can able to reach the destination point through free space or free space propagation. So in that aspect, the digital communication has more advantages than the analog communication and digital transmission. So this process, by combining the message signal, carrier signal, that is called as modulation process. In the reverse process, we have to remove the carrier signal from the modulated wave, that time we can obtain message. So in detail, if you are focusing on analog communication, if you are focusing on analog communication, so with a single expression we can able to differentiate the techniques. For example, If you are imagining a waveform, so in y-axis it is nothing but an amplitude, in the x-axis it is nothing but a time period. Either you can choose time or frequency, no problem, but you have to focus what is presented in the y-axis, whether it is time or frequency. Based on that only you can tell which one is low frequency or which one is high frequency. So V of t is nothing but that is a called sinusoidal waveform, right? So this is the amplitude. So this is the amplitude V. The waveform is sine, so it completes a cycle. So 2 pi ft, there may be some phase changes. So I can represent the sinusoidal wave in mathematically. V of t is equal to V into sine of 2 pi ft plus t. If any changes happen in the voltage alone, then the technique is called as amplitude modulation. By means of adding message signal with carrier signal, if you observe some changes in voltage, then the technique is known as amplitude modulation. If you observe any changes in frequency, then the technique is called as frequency modulation. If you observe any changes in theta, then it is called as phase modulation. So in one case, if there is changes in the amplitude, then it is amplitude modulation. Changes in frequency, then frequency modulation. Changes in phase, then phase modulation, but not at the same time. So only one relationship between the frequency and phase modulation is if we want to do frequency modulation, that time that will be a phase modulation. That is indirectly the phase will change. If you want to do phase modulation, but unfortunately there is a change in the frequency, nothing but a frequency modulation. So direct FM, it is also known as indirect PM. This is direct PM or indirect FM. So because if you are taking this is a frequency range, this is the angle value theta value. If I would like to minimize the cycle, so that time the duration will change, phase also change. My ultimate aim is I would like to change the frequency or phase. But if you change the phase, frequency also change. If you change the frequency, phase also change. So that it is called as direct FM or indirect PM, direct PM or indirect. So we can represent like this is our amplitude modulated wave, right? So if you are taking a message and a carrier signal, so based on the x-axis representation only, we can able to tell whether it is a message signal or carrier signal. So don't imagine that if that without any specification in the x-axis, we can't tell this is this one is carrier. So we have to get some idea about it. So for example, if you are taking time, then only this will be low frequency because the time is inversely proportional to frequency. So here also the same time. So we are having this agent here. So in amplitude modulation, the amplitude of the output is going to be varying. We look at the picture. We have to take the shape of the original waveform, or the sinusoidal waveform. So within that, we have the carrier signal. Right? This is amplitude modulated wave. This is message. This one is carrier. This is modulated wave. This one is modulated wave. Nothing but AM modulated wave. AM modulated wave. The shape remains same or constant. So this technique is called as this is nothing but envelope. because it covers the carrier signal, so this is called as the envelope. So we can able to detect this envelope by means of envelope detector in the demodulation, right? The important thing is we have to maintain the same shape in the receiver side. Suppose if we are trying to increase the amplitude of sinusoidal waveform, then there will be a phase reversal to be discussed. Now, if you are taking the modulation, right, we have a doubt which one is going to be whether they are going to vary the amplitude of the message or amplitude of the carrier. For example, if your message is nothing but your information, the carrier which is used to take your message to longer distance. For example, if you are taking this is our message or information, or I would like to transmit this information from the source to destination, that time this is considered a carrier because I don't want to send this directly, so I'm using this carrier. Suppose if I hold this information here, so that time I will cover the information and transmit to somewhere. Right? The receiver side they have to open this and they will get the same information. So if you change the information, that is if you change the information, then you will not get any information from it. In another case, suppose I would like to keep here, I would like to keep this information within this box, then I can able to transmit. Right? So this time also I have to mine the same information, not the carrier. Right? So same information is maintained. In another case, suppose if I want to transfer it in a very simple manner, I'm going to use this pack, right? And I'm transmitting. So in receiver side, they have to open this cover and they can able to identify the information. So in all these three cases, the information remains same. The only thing is carrier is getting varied, right? So the amplitude of the carrier is varied according to the instantaneous value of magnetic signal, that is called as amplitude modulation. If frequency of the carrier is varied in accordance with the instantaneous value of magnetic signal, then it is called as frequency modulation. Finally, phase of the carrier is varied according to the instantaneous value of the magnetic signal, is called as phase modulation. Thank you.